My dear students, now we will heading towards the third experiment, that is the double balanced mixer circuit experiment. In this section we will draw a double balanced mixer circuit, that is a diode double balanced mixer that I have created it's a type of double balanced diode mixer circuit that is comprised with four diodes, and four diodes uh, in a square shape with a bridge shape that you know as a Wheatstone bridge. The total connections has been made it here, and there is a generated frequency and there is a received frequency. Then both the other two frequencies are given here, and that the output will be the tapping of the transformer of the received frequency. Okay, we will get the output from the tapping of the as a center tap of the received frequency, and that is the port that we have given from here. If you just go through to the section like that, the connector section, the connector will be given here to find out the output section. Now the thing is that we have to check the frequency, that is frequency mixture means double balanced frequency mixture means that's the thing is that that is the generated frequency mixture. So in our experiment the given frequency was 6.2 megahertz. That's on the RF output number 1 board. So if that is output section, that is local oscillation input signal, so we have to change on the output section on the local oscillated signal. Okay, now there is a 2 volt and 200 millivolt. We have given this thing because to understand the changes of frequency mixing, that how much frequencies will mixed and what's the output. So that's gonna be the part, and that is also the center tap center tap transformer T1 has also been connected here, and here you can see that the center tapping has been grounded, and this center tap has been used for finding out the received frequency. So here you can see that is 200 millivolt in 2 volt. So we haven't changed it at all. We have to change the frequency out of it. So in that section, if I just use that is a 6.2 megahertz in the generated frequency, oscillator section frequency, we have to use just a very small frequency on that situation, not 5 megahertz. It should be on the kilohertz range. So let us try to 450 kilohertz. That is onto our own way, that we can take any kind of amount that is less than the oscillator frequency. So how that could operate. Now we will be heading towards the section of the simulation. Now the simulation starts. Now here you can see we will go through the grapher section. Now you can see there is a graph of the two parameters. Now the graph is there. Now we will split it. So there is an operating frequencies and other frequencies. The high frequencies are the high frequencies, and the output is the magenta color. It has been denoted in magenta color, and the blue color is for the same frequencies that has been came from the circuitry. Let us go to the circuitry. That is the green, blue colors and other things, and then that will go to the output right there. Now we have to check how much change that has been made. So there is, in the right section, there is a control section that we can check out that how much changes that can be made. While the simulating, we get this thing. Just make it clear. Here you can see that whenever you just change the oscillator voltage division section, you can check the factor that how much changes that has been made. So now just look at this section. Just that will be better than the previous one. And the thing is that there is some voltages. I have taken input as -2 +2 voltage, so 2.5 I should have to take maximum and minimum as that, as I have taken the input voltage as 2 volt. So that is gonna be the changes that I have to do. Now we have to stop the simulation now to find out this. Just stop it and go through to the factor. Now you can get through this. This is the final graphical representation of it. Now just check out it as a factor like that, that you should observe it. So how that can you observe it from there, that what happens in that situation. So there are the five probes that has been changed here: probe 1, 2, 3, 4. Yeah, the fourth probe is the output. So just leave all the things, that is the output section. After getting frequency mixed, that is the output frequency waveform. Okay, that is the observation of yourself, that you want to observe the frequency, how the frequency will look like. That is the output frequency, and you have to sketch this. You have to sketch this because this experiment wants the sketch out of it. Here you can see, you have to sketch this. You have to sketch the three waveforms, the TP1, TP2 and TP3. And that means the sketches between these, that is the output, that is the TP3 last sketch, and other uh, two factors is the PR1, that is the main functions, that is the that you can see that every square part of it is comprised with that, that is the input part. And the P2, that's overlapped with, just remove this, that is PR3. You have to sketch these two things, PR1, PR3 and PR4. In that section you have to sketch on your own hand. Just remove it, just remove these two things, that is a PR1, that is PR1. You can see, you can take a snapshot from here, the output 761. If you simulate this, you can easily get this thing. And then this PR3, if you want to PR1, just put the PR1. So same results but 90 degree shifted. The two things are 90 degree shifted, so we get the 90 degree shift here. Now just remove all this, just give to the PR4, that is the output section. The output will look like that. So that is your observation of double balanced mixer. So you have mixed these frequencies. Okay, so there are certain frequencies in the PR1 and PR2, and after PR3, and after mixing these frequencies, we get the output waveform like that, and the output frequency like the PR4, and that has been squeezed half of that part, because we have taken the center tap frequency. If we get the total frequency part, so that will be much more better than this, and you will get a larger value. So thank you very much for being with me for these double balanced mixer circuit. That is the circuitry, we want to draw and simulate it with the grapher, that I have told you how can you just control it by the right side section, that is the section, that is the settings section. So if you settings, go to the settings, start the simulation, check all the grids and all the things, so you can find out this. Thank you very much for being with me.